the limit from f of x as x approaches a. One option is a number that I can give you. I'm not saying I think it's approximate. No, no, no. I have to tell you what it is. If it is a number, then we say that the limit exists. It can be from the left, from the right, from either side. It doesn't matter. This is a general concept. We say that the limit exists. The second option is plus infinity, negative infinity, or dne. In all these cases, the limit does not exist. So then why do I write positive infinity or negative infinity? Because I cannot write dne. I write the dne only in this situation. Or in this situation. So let's say this is your preferred 7. So now I want to write, so this is our function. So I want you to tell me what is the limit as x approaches 7 from the right of f of x, and the limit as x approaches 7 from the left of f of x. And then I will ask you the limit as x approaches 7 from either side.
Would the top one be plus infinity?
Excellent. Who was that?
Megan.
Thank you. The other one.
Negative infinity.
Excellent. Who was that?
Nick.
Nick. And now conclude.
Does not exist. dne.
dne. What if it goes to both sides? Not this one does not exist, but it's here. You cannot write dne. You have to write one side is positive, the other side is positive, and the limit from either side is positive infinity. Positive infinity, positive infinity, positive infinity. Now, if I have positive here and negative here, I have to write dne. But if they're both negative, then I write negative, negative, negative infinity. So dne is only when one is on one side and one on the other, or approach to different numbers. Any questions? So obviously, when I say this, when I talk about this and I say the limit exists, then definitely both sides have to be the same. So when I say limit as x approaches a from either side of f of a is L, which is a number, this automatically implies that both limit from the left and from the right exist, and they're both equal to L. This is automatically understood. Any questions? Any questions? Okay, I would like to look at some graphs in the book. I am going to share my screen. Where are you guys? I can't see you now. Okay, got it. So I would like us to, where is my book? Okay, here it is. I want to go to page 102. So please open page 102 and let's work on different problems here. (102), 103. Okay. So let's start and practice what we just looked at. Okay, so let me choose the first one and then you choose the next. Okay, let's say for exercises 11 and 12, consider the function given by. So obviously this is a piecewise defined function. They are not showing us the work. That's fine because we have the graph. And it's asking us, so I'm looking at 11 and 12 if you want to write it down so we know what we're talking about. So let's choose, for example, 11. It doesn't matter. You choose the next one. So we are given the graph. We're not asked to graph it. We're asked to answer questions. So can anyone give us the answer to the limit as x approaches 3 from the left of f of x in this graph? How much will that be?
0.1.
Excellent. Does everyone see that? That's very important. Okay, the limit from the right. Stop me if you don't see it.
I don't see it.
From the left of -3? From the left of 3? Yes?
Yes.
Okay, follow my cursor. As x approaches 3 from the left, I put the cursor now on the function. The function values in that process get closer and closer. Closer and closer to which value of y of the function?
Okay, I see it.
Okay,
Thank you.
thank you. On the other side, don't be shy, please. On the other side, as x approaches 3 from the right,
Would it be 2?
it will be 2. Does everyone see the 2? And what will you conclude from either side?
Does not exist.
Why? Can anyone explain why it does not exist?
They're not the
Because
same number.
they are not the same number. Awesome. Okay, let's move on to this one. So let's look at few things here. You choose from 31 to 40, whatever you want.
36?
Which one?
36?
Is 36 I hear?
Yes.
Okay, perfect. The limit from h of x, here's h of x, when x approaches 1 from the left.
Would it be 4?
We all see it? As x approaches 1 from the left, the function gets closer and closer to 4. Do we agree?
Yes.
Okay. I want 39 now. Can anyone give us the answer for 39?
It does not
1.
exist.
Exactly. The function doesn't have, we were not asked whether the function is defined there. Who cares? We are only asked to determine the tendency of the function when x approaches 3 from either side. Because x does not equal 3. We already know that. By convention, when we say x approaches 3, we really mean it. Approaches does not equal 2. So the limit from either side is 1. We don't care whether the function is defined at that point or not.
Can we do number 34?
Yes. Any questions so far on that? Okay. 34. X approaches -2 from the right.
So would it be 1?
Exactly. As x approaches -2 from the right, the function values get closer and closer, closer and closer to 1. Now, if I ask you how much is f of -2, this is my own question. How much is f of -2?
2.
Excellent. How much is f of 3?
Undefined.
Undefined. That's exactly the correct answer. Undefined. Thank you. Who was that?
Nick.
Nick. F of 1. Four. But who cares? When we talk about the limit, we don't care about the function being defined there or not. I think so far we got the picture. Can I move on to the next page, or you would like to choose something else? Okay, so let's look at page 104 and see if there is anything in there. Yes, yes, very important. I knew it was going to do that. Oh no. No. I didn't mean that. Is it hidden somewhere? No, it's not. Oh no. Okay, it takes me back. So, I just want to put the page number. I think I can put it here. Yes, thank you. Where's my keyboard now? 104. Good, excellent. So back here to this graph. So let's say we're looking at you choose next. So I am going to say to pick. I want 45. Limit of f of x as x approaches 1 from either side.
Does not exist.
Exactly. Because the left limit goes where? Or is what? The left limit.
Infinity.
And the right limit?
Negative infinity.
Of course. As x approaches 1 from this side, follow the function. Over there. As x approaches 1 from this side, follow the function. Over here. So it's D and E. Please tell me if you want to choose anything else. Because I do. I want to choose at least 2 more.
We do 50.
50, very good. Awesome, yes. Again, just follow my cursor. X approaches infinity. X approaches infinity. 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 So now I follow the function. As x approaches infinity, I follow the function. Follow the function. Follow the function. Where does it go? Closer. Infinity would have been this. That's infinity. 1, exactly. They are trying to trick us. There is a horizontal asymptote at 1. So as x approaches infinity, the function is capped. It cannot, we say eventually may reach 1. If it were infinity, it would have been like this. Or in this case, it would have been like this. It will start here and go to infinity. But it's flat. Okay, perfect. What about 49? As x, yes?
Would that be 2?
Exactly, awesome. Who was that?
Tyler.
Tyler, thank you. So as x approaches negative infinity, the function values get closer and closer, closer and closer to 2. So that will be a horizontal asymptote at negative infinity, y equals 2, and at I want to write this down for you. I'm going to stop Sherry for a second. So we are going to write that limit of f of x as x approaches negative infinity was 2, which automatically means y equals 2 is a horizontal asymptote at, in this particular graph, this was problem, can anyone tell me what problem it was? At negative infinity only.
49.
Thank you very much. 49 in 1.1. Thank you. Also, limit of f of x as x approaches infinity was 1, which means exactly the same. Y equals 1 is a horizontal asymptote at infinity. Also, we realize that the limit as x approaches 1 from the left of f of x was infinity. You told me that. And the limit of f of x as x approaches 1 from the right was negative infinity. This automatically means that x equals 1 is a vertical asymptote for this function. By the way, a function can cross a horizontal, but never a vertical. So we can have functions that, let's say there is a horizontal asymptote, and the function could be like this. Let's say I'm going to also create a vertical asymptote. So the function can do this. Because this line has significance only here and here. It doesn't have any significance in the middle, but I cannot just draw this piece and tell you that there is a line there. I have to draw the entire line. But the function will never cross this line. Okay, back to sharing here.